Welcome to Study Loop.
So here, for part A, we're going to find the magnitude of the electric field at point P. So E, the magnitude of the electric field, would be equal to the voltage divided by the a length. This would be equal, according to Ohm's law, the current times the resistance divided by the length. This would be equal to 25.0 amps multiplied by the resistance of 1.00 ohms divided by the length of 300 meters. And we have an electric field of 0.0833 volts per meter. For part B, we're going to use Ampere's law. And essentially, we can say that B, the dot product between the magnitude of the magnetic field and the Poynting vector, the change in the Poynting vector, would be equal to the magnetic permeability in a vacuum times the current I. This would be the integral of the closed loop. And so the magnitude of the magnetic field would then be equal to B equaling mu naught I divided by 2 pi r. This would be equal to 4 pi times 10 to the negative 7th Tesla meter per amp times, again, 25.0 amps divided by 2 pi times 1.25 times 10 to the negative 3rd meters, being the radius. This is equaling 4.00 times 10 to the negative 3rd, and the units would, of course, be Teslas. For part C, we can say that the Poynting vector is going to equal the dot product between the vector product between the electric field and the magnitude of the magnetic field divided by the magnetic permeability in a vacuum. Therefore, this would be the magnitude. The magnitude would essentially be equal to the magnitude of the electric field times the magnitude of the magnetic field divided by the magnetic permeability in a vacuum. So this would be 0.0833 volts per meter multiplied by 4.00 times 10 to the negative 3rd Teslas. And then this would be divided by, here, it would be 4 pi times 10 to the negative 7th Tesla meter per amp. And we find that the magnitude of the Poynting vector would be 265 watts per meter squared. For part D, we finally find that since the Poynting vector points in the direction of the cross product of the electric field and magnetic field, we can say that we're going to use the right-hand rule, and essentially the direction of the Poynting vector at point P is in the negative y direction. That would be our answer for part D. That is the end of the solution. Thank you for watching.